Today chapter electrostatic potential and capacitor. Now to see one topic. Derive the formula for electric potential due to an electric dipole at a point from it. Mention the electric potential on the axis and on the equator for that electric dipole. A dipole is placed with origin at its midpoint. Its charges minus q and plus q are separated by a distance 2a. The magnitude of the dipole moment of the dipole is p is equal to 2aq and its direction is from minus q to plus q. Let point P be away from the midpoint of dipole and r1 and r2 are the distance of P from plus q and minus q respectively, which is shown in the figure. You can see in figure. The potential due to the charge plus q at a point P is V1 is equal to K in bracket plus q upon R1, and the potential due to charge minus q V2 is equal to K in bracket minus q upon R2 is equal to minus KQ upon R2. According to superposition principle, the total potential at point P V is equal to V1 plus V2 is equal to KQ upon R1 minus KQ upon R2 is equal to KQ common in bracket 1 upon R1 minus 1 upon R2 bracket over equation 1. Draw QN perpendicular OP in triangle QON. Triangle QON is equal to theta, you can see in figure. Therefore ON is equal to R minus R1 and cos theta is equal to ON upon OQ, implies that ON is equal to OQ cos theta. Therefore R minus R1 is equal to A cos theta, implies that R1 is equal to R minus A cos theta. OQ is equal to A. Therefore R minus R1 is equal to R in bracket 1 minus A upon R cos theta bracket over squaring both the side, implies that R1 square is equal to R square in bracket 1 minus A upon R cos theta bracket over squaring both sides is equal to R square in bracket 1 minus 2A cos theta upon R plus A square upon R square cos square theta bracket over. Putting R greater than A implies that A square upon R square is equal to 0. Therefore R1 square is equal to R square in bracket 1 minus 2A cos theta upon R bracket over, and draw OM perpendicular in bracket minus QP. Then in triangle in bracket minus QOM, O in bracket minus QM is equal to theta and bracket minus QM is equal to R2 minus R. Therefore cos theta is equal to in bracket minus Q capital M upon O in bracket minus Q, implies that bracket minus Q capital M is equal to O in bracket minus Q cos theta. Therefore R2 minus R is equal to A cos theta, where O in bracket minus Q is equal to small a. Therefore R2 is equal to R plus A cos theta. Therefore R2 is equal to R in bracket 1 plus A upon R cos theta bracket over equation number 4. Therefore R2 is equal to R in bracket 1 plus A upon R cos theta bracket over equation number 4. Therefore R2 square is equal to R square in bracket 1 plus A upon R cos theta bracket over squaring both the side is equal to R square in bracket 1 plus 2A upon R cos theta plus A square upon R square cos square theta bracket over. If we take R greater than A, then the value of A square upon R square can be neglected. Similarly R2 square is equal to R square in bracket 1 plus 2A cos theta upon R bracket over equation 5. Now from equation 3, 1 upon R1 is equal to 1 upon R in bracket 1 minus 2A cos theta upon R bracket over raised to minus 1 half is equal to 1 upon R in bracket 1 plus A cos theta upon R bracket over number 6. Only two terms be taken for expansion, and therefore 1 upon R2 is equal to 1 upon R in bracket 1 plus 2A cos theta upon r bracket over raised to minus 1/2 is equal to 1 upon r2 is equal to 1 upon r in bracket 1 minus a cos theta upon r bracket over equation number 7. Now from equation number 5, putting the values of equation 6 and 7 in equation number 1, v is equal to kq big bracket in small bracket 1 plus a cos theta upon r bracket over minus small bracket 1 minus a cos theta upon r bracket over, after that big bracket over, is equal to kq upon small r in bracket 2a cos theta upon r is equal to kp cos theta upon r square is equal to kq upon r in bracket 2a cos theta upon r bracket over is equal to kp cos theta upon r square. Here 2aq is equal to p is equal to k vector p dot unit vector r upon r square is equal to k vector p dot r cap upon r square. Therefore p cos theta is equal to vector p dot r cap unit vector. Therefore v is equal to vector p dot r cap upon 4 pi epsilon 0 r square, or p cos theta upon 4 pi epsilon 0 r square, or kp cos theta upon r square, and r cap is equal to vector r upon r by putting v is equal to 1 upon 4 pi epsilon 0 vector p dot vector r upon r cube. Vector r perpendicular to vector p on the equator, hence theta is equal to 90. Therefore v is equal to kp cos 90 upon r square. Therefore v is equal to 0. Vector r parallel to vector p on axis, hence theta is equal to 0. Therefore v is equal to kp cos theta 0 upon r square is equal to kp upon r square. Hence potential due to a point charge decreases according to 1 upon r, and potential due to a dipole decreases according to 1 upon r square distance. The molecular dipole are very small, and such an approximation is very well appreciable to them.